Bismillahirrahmanirrahim. Dear guys, let's solve the problems on exam view on chapter 6. Number 1. Person X pushes twice as hard against a stationary brick wall as person Y. So we have two people. One push the stationary brick with a force, and the second push the same stationary brick wall with twice the force. Which one of the following statement is correct? Put in your mind that the brick wall is stationary. It is not moving. You know well that W equal F times D. So the work equal force times distance. So if the brick is stationary, so there is no work is done by both. So both do positive work? No, the work is zero because the brick is still stationary, not moving. Both do positive work, but person? No, both do zero work. Both do the same amount of positive work? Wrong, both do zero work. Why? Because the brick wall is still stationary, at rest. Number 2. Two men, Joel and Jerry, push against a car that has stalled, معطلة. It is not moving, trying unsuccessfully to get it moving. So it is not moving at all. Jerry stops after 10 minutes, while Joel is able to push for 5 minutes longer, means 15 minutes. Compare the work they do on the car. Put in your mind that W equal F times D. There is no displacement, so there is no work is done. So he said Joel does 75% more work than Jerry. Joel does 50% more work than Jerry. Jerry does 50% more work than Joel. Joel does 25% more work than Jerry. Neither of them does any work. Why we choose that? Because the car is stalled, not moving. They trying unsuccessfully to get moving, but it is not. So the work equal zero. Number 3. If the force on an object is in the negative direction, so you have object here and the force in negative direction. This direction is positive and this direction is negative. The work it does on the object must be negative, positive, or the work could be either positive or negative. Yes, this is the right answer because you know that W equal F times displacement or distance. So the work, it depends on the force and also the direction of the force and the direction of the displacement. So the work could be either positive or negative depending on the direction of the movement. Right, guys? Depending on the direction of the movement. Number 4. 35 Newton bucket of water is lifted vertically 3 meters up and then returned to its original position. How much work did gravity on the bucket? If the gravity did negative work while the object is going up, because the gravity direction is downward, right? So the work done upward is negative. And it moves, the gravity or the bucket moves under the effect of gravity downward, right? So the same work but with positive sign. So the total amount of work equals 0 because the work to lift it upward exactly equal the work the gravity did on the bucket downward. So the total amount of work equals 0, because the work to lift the bucket upward exactly equal the work to let the bucket go downward, and one of them has a negative sign as the other. Number 5. You throw a baseball straight up. Compare the sign of the work done by the gravity while the ball goes up with the sign of the work done by gravity while it goes downward. You know well that in the first movement, the ball goes upward and the direction of gravity is downward. So the work is negative while the baseball goes up. And when the baseball goes down with the same direction as the gravity, so the work positive. So the work is positive on the way up, wrong, because it is in opposite direction as the force of gravity. The work is positive on the way up, wrong. The work is negative on the way up, yes, because it is in the opposite direction as the force. And the positive on the way downward, yes, because it is in the same direction as the force. So the right answer is letter C. Number 6. Which one has larger kinetic energy? 500 kilogram object moving at 40 meters per second or 1000 kilogram moving at 20 meters per second. Let's calculate the kinetic energy for the first object. Kinetic energy 1 equal half M1 equal 500 times V1 square equal 40 square. Right? So half 500 250 times 1600, it equals 400,000 joule. The kinetic energy for the second object equal half the mass 1000 times 20 square. Half 1500 times 400 equals 200,000 joule. So the kinetic energy for the first object is larger than the kinetic energy for the second object, right? He asked which has larger kinetic energy, so the 500 kilogram object. So the effect of increasing speed, the effect of speed is larger than the effect of the mass. Here the speed is double. In the first case the speed 40 meters per second. In second case the speed is 20 meters per second. In first case the mass is 500. In second case the mass is 1000. So better to increase the speed than increasing the mass of the object, because you know that kinetic energy equal half mv squared. So doubling the speed quadruple the kinetic energy, but doubling the mass double the kinetic energy, because the square of the speed it quadrupled the kinetic energy. So as you see, the one that has larger speed has larger kinetic energy, the first object. Let's solve number 7. A truck has 4 times the mass of a car. So M truck equal 4 M car. And is moving with twice the speed of the car. So V truck equal 2 twice the speed of the car, V car. If KT and KC refer to the kinetic energies of the truck and the car respectively, it is correct to say, let's calculate the KT. KT equal half, MT equal 4 MC times VT equal to VC square. So half times 4 MC times 4 VC square. 4 times 4 16. So 16 times half MC VC square. I arrange it. 4 times 4 equals 16, and this is half MC VC. What we call this part? Half MC VC square. It is equal KC. Kinetic energy for the car equal half M car V car square. So kinetic energy for the truck equals 16 times the kinetic energy of the car. So the right answer is letter A. Let's move to the next one. Number 8. 3 cars, car F, car G, car H, are moving with the same speed and slam on their brakes. The most massive car is F, and the least massive car is H. This is the most massive. If the tires of all 3 cars have identical coefficient of kinetic friction with the road surface, which car travel longest distance to skid to a stop? When you use the brakes, you apply a work, right? So the whole kinetic energy, the work will equals the work that the brakes use will equal the change in kinetic energy, right? Equal half mv final square minus half mv initial square. This is equal 0. So F applied by the brakes times distance equal negative half mv initial square. F, it is the force of the brakes, right? It equals, it is force of friction, equal mu times N, right? Times S, equal negative half mv initial square. Mu times N is the normal force, equal mg. S equals negative half mv initial square. M is the same here. If we apply this for the 3 cars, for car F or car G or car H, M will goes here and there. Mu is the same for the 3 cars. He said that the 3 cars have identical coefficient of kinetic friction. So mu is the same. G is the same. V initial is the same. So the distance is the same. So they all travel same distance in stopping. And this is the answer. I hope you got it. For number 9, 3 cars L, M, and car N are moving with the same speed and slam on their brakes. The most massive car is L, and the least massive is N. If the tire of all the 3 cars have identical coefficient of kinetic friction with the road surface, for which car is the amount of work done by friction in stopping in the greatest? Sure, the work done to stop the very large mass is larger, because W equal F times D, and F friction equal mu in D or S, whatever you call it, mu times mg D or S. For the large massive car, the work will be larger, right? So which car is the amount of work done by friction in stopping is the greatest? So the larger mass, so car L. Let's move to number 10. 4 kilogram object is moving with speed 2 meters per second. 1 kilogram object is moving with speed 4 meters per second. Both objects encounter the same constant braking force, same force, and are brought to rest. Which object traveled the greater distance before stopping? You know that the work done by the brakes F equal F times S. F1 S1 equal the change in kinetic energy for the first car, negative half M4 times, half means in opposite direction because it is braking force, encounter the movement of the car. The speed square 2, so equals 8 joule. This is W1. W2 equals F2 S2 equal negative half the mass of the second 1 kilogram times the speed is 4 square, so it equals negative 8 also. F1 equal F2, so S1 equal S2, so both objects travel the same distance. We'll complete the next problems in next video. God bless all of you. كان معكم Mr. Ibrahim Sultan, Physics and Chemistry teacher.